Alright, hey everyone, my name is Sam, and I made Forged. Browser use agents are smart. They can do anything on the web. But the problem with them is they're super slow, and slow means expensive, and dumb in some cases. What if we could make them faster? They do a lot of repetitive work. They take a screenshot of a link that they've seen before, a website that they visited 100 times before. They pass it to Claude, wait 3 seconds, analyze it, and call the tool. The thing that they have done always, and nothing is specific about it. It's the baseline task that all of them needs to do in order to achieve that point that we actually need LLM intelligence for analysis or tool capabilities. What if we could change that? An Iranian-made Shahed 136 drone is $25,000, and a US-made Tomahawk cruise missile is $2 million. The difference isn't the capability. They both hit the target. The difference is Shahed follows the pathway that it's seen before, and it only changes when it's needed. What if we could do the same thing with browser agents? So let me show you. We have an RL environment. Think about it that way. We have this page here called Learn. We can teach model new skills. For example, here, for the sake of time, I've already done this, and I asked the model to go to Wikipedia and search for artificial intelligence and extract the first paragraph of the article. So what it done, it was just a baseline browser use model, nothing specific about it, that just done the task. And here it is. It started it, and it learned something really specific. What are the repetitive tasks that we can just copy and paste with Playwright? It learned the DOM elements, it learned what is static and what is not, and how we can do it. And the skill is learned. For example, if we want to teach you something new, we can just say go to Hacker News, click on the top story on the front page, and extract X, Y, and Z. And this way, the model is going to learn when it's doing something. Now let's race them. But I'm going to change something specific. In the training, we said go to artificial intelligence page and extract the first paragraph. But I'm going to change that to dog. And first and second paragraph. Why am I doing this? Because, for example, a user might do a task with Forge, and we don't know that. And after when the task is done, our model has learned that through reinforcement learning. But what if someone else has the same thing, but there are just simple differences, such as a name, such as some basic things? That's such a waste of opportunity. So what we do here is we're going to get a cosine similarity in our vector database that is growing every time that someone uses Forge, and figure out if we have a template, a Playwright template, to do this task. For example, we found one with 100% accuracy. So we launched a race. At the left side is the baseline, the browser use model that we all have access to. At right, it's Forged. It's browser use plus Playwright. As you can see, it did the task in 10 seconds. This is the first paragraph and the second paragraph. There was no agent involved in this entire process. You might ask, how we have this data? This is obviously generated from the screenshot that we have here. We only take a screenshot off of it and pass it to a very fast and cheap model to analyze things for us. We can decide when it's needed to just call an LLM to analyze a screenshot, or when it's needed to have an agent to actually do agentic work for us. As you can see, it's already been 4.2x faster than the baseline model. The difference here is this is not running an agent. The agent isn't analyzing things, and we're not having that super expensive process. It's just manual work that has been learned before. Right now, you can see that the baseline model is done after 61 seconds. This is the first paragraph and the second paragraph, and you can see they're identical. That was 5.6x faster. That is 50 seconds. Imagine thousands or millions of these 50 seconds that happen in production. And every time that these 50 seconds are saved, we learn new things. And those 50 seconds turn to 60, 70, 80. These are the benchmarks that we have so far. On average, Forge managed to increase the speed and beat browser use models by 4.7x. That is a lot of time across 11 races that we had so far. There was a bug here. It doesn't count. But for some tasks, we see dramatic increases, such as Hacker News. We did that in 8.3x faster than the baseline model, simply because the task was the same. Go to the top post, extract the top 3 comments. And that's static. We can change it. We can say, go to the second post and extract the top 8 comments. The next thing that I want to show you is Forged AI SDK. It's an MCP server that lets Claude Code, Cursor, or any agentic tool that has access to MCP use Forge. So we can go to Quick Start and copy this curl command. And we can go to our terminal, install it, and here we are. Now, I'm just going to use Claude Code for one of these tasks. For example, go to Hacker News and get the top story. What is super interesting about this is all these agents are using the same vector database. That means the more community uses this, the more tasks it's going to learn, the more skills it's going to learn. And next time that someone asks it, go to Hacker News and get the top story, it's going to do it in 3 seconds because there's no LLM needed. It just knows where's the top story, it knows the DOM elements, it knows the HTML elements. And you might ask, what if the DOM elements are changed? What if the HTML elements are changed? They changed it. What we're going to do is we're going to compare the DOM elements that we have in the vector database with what we see, what is being rendered. If it's different, we're going to mark that skill as expired, and we're going to run that again. So we have an updated skill, and we know what works and what doesn't work. As you can see, it's completed, and it used Forge. And as you can see, this is the entire logs in the backend server. And if we run this again, Forge is going to know how to do it faster. And eventually, we have this chat interface that you can ask anything from Forge, and it'll do it. It's basically browser use under the hood with the SDK that we made with the MCP. And if it knows that task, if it has the template in the vector database, it's going to extract the parameters and it's going to do it. And if it didn't know the task, it's going to just learn it and add it to the vector database, and it grows over and over and over again. Thank you so much.